Welcome to Intelligence Gateway.
Module 3, Data Integration for Data Warehousing. Data integration is a critical step in the process of building a data warehouse, as it involves bringing together data from various sources, transforming it into a consistent format, and loading it into the data warehouse for analysis and reporting. Data integration is typically performed using ETL, extract, transform, load processes, which involve extracting data from source systems, transforming it into a format suitable for the data warehouse, and loading it into the data warehouse. Here are some key concepts and techniques related to data integration for data warehousing. 1. Data extraction. Data extraction involves extracting data from source systems, which can include databases, applications, external data sources, or other systems. Data may be extracted using various methods such as batch processing, real-time streaming, or incremental updates, depending on the requirements of the data warehouse and the characteristics of the source systems. 2. Data transformation. Data transformation involves converting and modifying data extracted from source systems into a consistent format that can be stored and analyzed in the data warehouse. Data transformation may involve various tasks such as data cleansing, data validation, data enrichment, data aggregation, data normalization, and data integration. Data transformation may also involve applying business rules, data validation rules, and data quality checks to ensure that the data is accurate, consistent, and valid. 3. Data loading. Data loading involves loading the transformed data into the data warehouse for storage and analysis. Data loading may be performed using various techniques such as batch loading, incremental loading, real-time loading, or streaming data loading, depending on the requirements of the data warehouse and the characteristics of the data being loaded. 4. Data integration tools. Data integration tools are software tools or platforms that provide functionalities for performing ETL processes. These tools typically offer features such as data extraction, data transformation, data mapping, data validation, and data loading, and may also provide data profiling, data quality, and data governance capabilities. Examples of popular data integration tools include Apache NiFi, Talent, Informatica Power Center, Microsoft SQL Server Integration Services, SSIS, and IBM InfoSphere DataStage, among others. 5. Data integration patterns. Data integration patterns are design patterns or best practices that provide guidelines for organizing and implementing data integration processes. Some common data integration patterns include batch processing, trickle processing, real-time processing, change data capture, CDC, data federation, data consolidation, and data virtualization. These patterns help in designing efficient, scalable, and maintainable data integration processes that meet the requirements of the data warehouse. In summary, data integration is a critical step in building a data warehouse, involving the extraction, transformation, and loading of data from various sources into a consistent format in the data warehouse. It requires the use of data integration tools, adherence to data integration patterns, management of data integration challenges, and consideration of data security measures to ensure the accuracy, consistency, and security of data in the data warehouse. Data integration techniques. Data integration techniques refer to the different approaches or methods used to combine and merge data from various sources into a unified format for analysis, reporting, and storage in a data warehouse. Here are some common data integration techniques. 1. Batch processing. Batch processing is a common data integration technique where data is extracted from source systems in large volumes at scheduled intervals, transformed into a consistent format, and loaded into the data warehouse. Batch processing is typically used for processing large volumes of data and is suitable for scenarios where near real-time data is not required. 2. Real-time processing. Real-time processing, also known as near real-time processing, involves capturing and integrating data from source systems in near real-time or in real-time as it becomes available. Real-time processing is used when up-to-date data is critical for analysis and decision-making, such as in online transactional processing (OLTP) systems, where data changes need to be captured and processed immediately. 3. Change data capture, CDC. Change data capture, CDC, is a technique that captures and records changes to data in source systems and propagates those changes to the data warehouse in near real time. CDC is often used in scenarios where only changes to data need to be captured and processed, rather than processing the entire dataset, to reduce processing overhead and improve efficiency. 4. Data federation. Data federation is a technique that allows data to be integrated from multiple sources without physically moving or copying the data to a central location. Instead, data is accessed and integrated in real time or near real time from the original source systems, avoiding the need for data duplication and ensuring that the data in the data warehouse is always up to date. 5. Data consolidation. Data consolidation involves combining data from multiple sources into a single, unified format in the data warehouse. This may involve data mapping, data transformation, and data integration to ensure that data from different sources is aligned and integrated into a consistent format. These are some common data integration techniques used in data warehousing. The choice of data integration technique depends on factors such as the requirements of the data warehouse, the characteristics of the data sources, the timeliness of the data needed, and the complexity of the data integration process. Data extraction. Data extraction is the process of retrieving data from one or more sources and collecting it for further processing or analysis. In the context of data warehousing, data extraction is a critical step in the ETL, extract, transform, load, process, where data is extracted from various source systems, transformed into a consistent format, and loaded into a data warehouse for storage, analysis, and reporting. Data extraction typically involves the following steps. 1. Identifying data sources. The first step in data extraction is to identify the relevant data sources from which data needs to be extracted. This may include databases, data files, APIs, cloud-based applications, external systems, or web services. 2. Data source connectivity. Once the data sources are identified, the next step is to establish connectivity to these sources. This may involve setting up database connections, establishing APIs, configuring data file access, or connecting to external systems or web services. 3. Extracting data. After establishing connectivity, data is extracted from the identified sources using appropriate data extraction techniques such as SQL queries, APIs, file parsing, or data replication methods. Data may be extracted in full, i.e., all data from the source, or incrementally, i.e., only the changes or additions since the last extraction. 4. Data validation. Extracted data is validated to ensure its accuracy, consistency, and completeness. Data validation may involve checking for data integrity, data format, data type, data range, and data quality to ensure that the extracted data meets the required standards.
Thanks for watching. For more information, like, comment, and subscribe our channel.